Hey Chem students, I am excited to do a demo for you today. I've got some blue liquid here and I've got some blue liquid here, and colors are always pretty, right? And hey, Easter's coming up, so I don't know, pretty Eastery colors here. And hey, I had a nephew born. I guess this light blue reminds me of my little nephew that was born on March 14th. Let's see. Was that Saturday? So he's actually a Pi Day baby, and that was pretty sweet. So I told my brother, you guys have to have pie to celebrate his birthday every year. So anyway, hey, I also want to show you guys something I bought. I bought one of these. I'm pretty excited. I bought a Roku device. I'm kind of behind the times, but 'tis the season for having a Roku device. So anyway, just thought I'd randomly share that. Okay, so we're going to talk about something called ocean acidification. Ocean acidification. And right now in chemistry we're studying acids and bases. And so in our atmosphere right now, carbon dioxide is building up. All right, and if you look up atmospheric carbon dioxide graphs, you can see that it's just kind of gradually increasing, and now we're to maybe 420, 430 parts per million, way higher than the amount of carbon dioxide before the Industrial Revolution. Okay, now there's a couple things that happen when carbon dioxide gets into the ocean. So first of all, as carbon dioxide builds up in the atmosphere, a lot of that atmospheric CO2 is absorbed by the oceans. In fact, probably about a fourth of it is. Okay, and so at first scientists were excited about that because they're like, hey, the oceans are absorbing a lot of the carbon dioxide, and that's a good thing. Well, here's a couple of chemical reactions that can happen when carbon dioxide gets added to seawater. First, this one can happen. Okay, carbon dioxide combines with water, and it makes this stuff right here, and we call this carbonic acid. Okay, now if you have an acid, that means that it is producing lots of hydrogen ions in solution. That's what makes something an acid, is it creates a lot of extra hydrogen ions, and then you measure the pH, and you can, that's why it has a lower pH, is because there's a higher concentration of hydrogen ions. So this carbonic acid is produced. Now seawater actually is a little bit basic. It has a pH of 8.06. So when we say ocean acidification, the oceans are not acidic, but they're moving toward being acidic. So right now the pH of the oceans is 0.1 less than it was before the Industrial Revolution. And you may not think that's a big deal, so 0.1 less, but remember the pH scale is logarithmic. So a pH change of 1 is a difference of 100 times. So a pH of 0.1 less is about a 30% greater acidity, okay, than before. So it is significant. The other chemical reaction that can happen with more CO2 in the oceans is this one. You can get carbon dioxide combining with water, and then combining with this polyatomic ion called carbonate. If you guys remember your naming your formulas, you guys had that list of polyatomic ions. This one was on there. It's called carbonate. And carbonate is something that marine animals, like clams, like corals, like starfish, they need that to build their tough shells or their tough outer layers. A lot of little microscopic algae too, they need that carbonate ion. But what happens is carbonate usually is free floating in the seawater, and the animals can snag that and use it to build their shells. But with more CO2, it creates this chemical reaction, and we get this new molecule made called bicarbonate, and the bicarbonate locks up the carbonate, so it's no longer usable for animals. So what happens, the animals can't build their shells, because there's not a bunch of carbonate available like before, and then they can't maintain their shells very well either. Okay. So what I have here, sorry about the blab here, I'm finally getting to the demo. Right here I have, I'm gonna say that this beaker represents the oceans before the Industrial Revolution. Okay. And there was a fair amount of carbon dioxide in the atmosphere back then, in the pre-industrial revolution days, but not near as much as today, because we burn our fossil fuels, we drive our cars, we burn our coal, and we ship goods all around the world. We order from Amazon, and trucks have to bring it to our house, and that burns fossil fuels. And so we're putting a lot more CO2 into the atmosphere. Although we are staying home a lot right now, and that means we're driving a lot less. But anyway, so I'm gonna, I just have water here, and I put bromothymol blue indicator in here. It's the same stuff you guys use for the titrations. And right now, this bromothymol blue is blue, which means it's basic. It's a little bit basic of a solution. But when that turns greenish or yellowish, that means it's acidic. It's officially acidic. So I'm going to breathe through this straw, and breathing through the straw is going to represent the amount of carbon dioxide produced in pre-industrial revolution. Okay, before that, before our factories and our fossil fuel burning happened. And so anyway, here we go. You kind of watch the change here. Might take a bit. Try not to blow it in my face. You having fun yet? I am. All right, I'm going to stop there. Thank you. But you can see it's kind of turned this greenish color. So that shows it's getting more acidic. There you go, closer to the camera. It's getting more acidic. It's turning that greenish color. All right. So a little bit of carbon dioxide. Again, this reaction here is happening. Carbon dioxide plus water. Carbon dioxide, as I blow through the straw, is making this carbonic acid, and it's making the indicator is changing color, telling me it's getting more acidic. Now, let me grab something else to represent the carbon dioxide produced in the Industrial Revolution today. So fortunately, Smith's did not run out of dry ice. Okay, so I have a little bit of dry ice here. And I have way too much here because I was going to originally do 3 demos for 3 classes, but I might just have to find ways to play with this later. I'm just going to go ahead and add a chunk of dry ice here. Now, dry ice, if you're not aware, is solid carbon dioxide. And the reason you see the steam coming off, it's carbon dioxide gas is coming off there. And one cool thing about carbon dioxide is it undergoes sublimation. So instead of melting, it goes immediately from solid to gas. And it sublimes, we say. So anyway, let's go ahead and throw this. This is our Industrial Revolution ocean. Okay, we're making lots of cool bubbles here. Scoot this up a little bit. I should have done this at Halloween time. This is so fun to play with this stuff. Kind of play with the gas here. All right, notice the color change going on. It's pretty rapid. Okay, now we're going to a pretty solid yellow here, not just a green. I'm going to be right back. I'm going to get some pH paper. I'm just curious what will happen if we add a little bit more of the indicator. We might get a brighter yellow. Yeah, we do. Okay, so that is definitely an acidic solution. Right, and like I said, the oceans are not acidic, but they're moving that way. The pH is getting lower. All right, just for fun, I'm going to take some, play with that a little more just for fun too. Come grab some dry ice from me if you want to play. Well, assuming it's still there, it kind of disappears after a while. Okay, I'm just going to take some pH paper here. This is the orange stuff you guys played with. Let's take the pH first of our pre-industrial revolution ocean here. And I'm getting kind of a green color on that one. So I match it up. I match it up here with my color chart, and looks like it's a pH of about 8. Okay, maybe 7, 7.5. I guess it's kind of seems like it's gone back a little bit blue. Yeah, then I'll go ahead and take pH of this. Woo. And we have a very solid orange there, or kind of a orangish yellow, and that's about a pH of 6 right there. Okay. All right, well, I hope you guys have enjoyed the demo. One thing to keep in mind is that in the past, as little critters in the ocean, corals, mollusks, algae, as they built their shells, those shells are made out of calcium carbonate, right? So they got these carbonate ions from the ocean, and they got calcium ions from the ocean. But how were those replaced? Like when they built their shells, how were those replaced? Well, it was from weathering of rocks. So rocks would be weathered and chipped away from different forces, and that would, as the rocks weathered, the calcium and the carbonate in those rocks got back into the ocean. So it was kind of this cycle, and so that could be replenished. But now, because of increased CO2 that we're cranking out, too much of this is being used up and locked up here in the bicarbonate, and the weathering of rocks can't replace that and the calcium fast enough. Okay, so I just encourage you to think of ways you can reduce your carbon footprint. That's kind of the buzzword nowadays. Nowadays, things you can do to reduce burning of fossil fuels. Thanks, guys.